I purchased this item with the intention of actually using it in a piece of equipment myself, and I did in fact install it in a piece of equipment and soon found that it didn't perform anywhere near to expectations. At that point I took it out of the piece of equipment again, thought I'd do a capacity check on it. The result of that was 2145 mAh. I hadn't actually intended to make a video on this guy at the time, so I didn't actually record any footage. So at that point I then decided to start making the video, which you can see coming up now. So here the battery is. Already there's something quite concerning just printed on the label. We can see here that the charging voltage is 12.8 volts and the nominal voltage is supposed to be 12.8 volts, and it's supposed to be 32700 cells, which are Lifepo4 cells. So that just doesn't add up at all. So this is the item that I purchased. I have covered up the seller's name just to keep them anonymous. And as you can see from the details, it's supposed to be a 32700 cell of obviously 4 cells, 12.8 volts nominal voltage, 7000 mAh battery pack, Lifepo4 with a 4S 7 amp balanced BMS. So here's the actual page for the battery itself, and we can see here that it's got a working current of 5 amps, effective voltage 14.4 volts, charging current 2 to 3 amps, charging voltage 14.6 volts. And we can come down to the specifications here. So it's got the brand, 12.8 volt nominal voltage. The Lifepo4 batteries actually have a nominal voltage of I think 3.2 volts. There should be 4 of those to give you a nominal voltage of 12.8 volts. Capacity 7 amp hour. It's actually saying it's got a 40 amp balanced BMS board here. The charger is not supplied at that price, you have to pay an additional charge for that. And just for clarity, you can see here that I was actually refunded by AliExpress for this item. I think what we'll do is just open this guy up and actually look to see what's inside it. So I'm going to try and approach this by gently cutting round in the groove, and we'll see what happens. Hopefully nothing disastrous, but we'll find out. Right, at this point I just want to see if I can break into it. I'm not sure if I will be able to. I'll give it a go. No. Okay, let's go a bit deeper. Okay, have another go. That's certainly a lot closer. Obviously I don't want to put a metal tool into this thing too deeply. Being quite tentative here for obvious reasons. It's the first time I've ever done this, so okay, I'm just going to go a bit deeper there. Okay. Making progress slowly. There we go. That's certainly interesting. Okay. Well, we've definitely got 4 cells. Can't say that they look particularly new, to be honest. Yeah, I think I can clearly see that these are not new cells. These are clearly have been used already. There's the BMS. Okay, let's just measure the voltages on these cells, just out of interest. So we've got 3.1, 3, 2.8 and 3.2. So just on some general observations, I'm going to fully charge this up again, but we can see, hopefully you can see that these cells are definitely not new. They're very dirty. There's several marks all over them that aren't related to the paper that's actually been stuck on them to make this particular battery. The connecting strips are very rough, very cut nastily, very sharp. It's not been done professionally, and the soldering is not great. It's the same on both sides, and there's a lot of marks and scuffs and damage, generally speaking. Okay, so we can see here this damage here with some corrosion underneath. Generally speaking, these cells are in very second-hand condition. I'm going to fully charge it up again in series using the built-in BMS and see what voltage we can actually get these up to, and then we'll continue from there with the video. Okay, so some time has passed, and the charger is actually set for 14.5 volts, and it's cycling on and off. So for some reason the BMS is not allowing the battery to charge any more than this. Presumably one of the cells is going over voltage. So let's just check the voltages on the cells. So we've got, I'll just disconnect the charger for a moment. Okay, so the first cell we got 3.5, and we've got 3.44, 3.36 and 3.42. So presumably one of these cells is going over voltage and is shutting down the charger. So it's charging now, charging. We'll keep monitoring that. It's shut off. So it seemed to shut off at 3.75. So we've got one cell that's going up to 3.75. And the other cells are not even close to that. So it would appear that the BMS has not actually functioned correctly. It's not actually balancing the voltages. So what I've done is I've actually turned the charge voltage down so it limit the maximum voltage across the cell to 3.67 at the moment. I'll just go down a little bit more, like that, at 3.65. Okay, 3.65. So let's leave it like this and charge at this voltage until it stops charging, see if I can actually get these all balanced. So I'm going to leave it like this for a while and then I'll come back. So I've been steadily increasing the charge voltage here for some time because it doesn't appear that the balancing circuit works. I'm assuming that the capacity of these cells are quite varied, and during the initial charge one cell will rise much higher voltage than the other three. I think it was this one, went up to 3.75, which causes the charging to shut down. I reduced the charge voltage to get a maximum of 3.65 across this cell, and slowly the other ones have started to catch up. So let's just measure these. So the first cell here, 3.6. The second cell we got 3.62. The third cell we got 3.73, so that's getting quite close to shut off voltage, that one. And then the third cell is 3.63. So yeah, so it seems to be this first cell here that is causing the majority of the problems. That's 3.599. Second one is 3.62. We've got 3.73 and 3.63. So we've got a little while to go on this cell before it's fully charged. Now I'm hoping if I leave it, it's just going to trickle charge this cell to bring the voltage up. Okay, I'm just going to leave it for a bit longer and we'll see if we can get the cells balanced, and then I'll do another load test and to see the capacity after doing a balanced charge, and then we'll measure the cell voltages after that to see which ones are worse. Okay, so a bit of an update. It's been on charge for some time still. And then we'll measure the cells. So this one we've got 3.61, 3.66, 3.67 and 3.63. So it's getting very close now. I'll leave it for a bit longer and see if it gets any better than that. Okay, so this is actually the next day. I've left it trying to balance overnight. So we've got 3.68, 3.63, 3.66 and 3.61. so that is the best it can achieve with the balancing. These cells appear to be in quite a varied state of wear. So at this point I'm just going to do a final load test. I've got this set for a constant current discharge of 0.5 amp. So let's just reset that. Okay, so we're back to 0 amp hours. Okay, so we can see the battery voltage here is saying 14.36 thereabouts. So let's start the tests, and I'll leave it on until I've got it actually set to stop at 9 volts, but I think the BMS will shut down way before then. So we'll let it run until the BMS actually shuts it down, and we'll see what capacity we get. So here we go. So the test has been running for around an hour so far. We can see that the battery voltage is already down to 12.41, and the capacity so far is just over half an amp hour, 508 milliamp hours. So some considerable time has passed and the test has come to an end. So we can turn this back on and see what the status is. So the total capacity of the battery, so this is after a complete balance charge, is 2.94 amp hours. The voltage is currently at 1.85 volts, which must be the BMS has actually shut down. So let's measure the individual cells. Let's just disconnect this. Okay, so the first cell we have 3.23 volts. The second cell 2.4. Okay, so that's the one that's really down. And the third cell 2.95, and the last cell 3.1. So the second cell here is the one that's really down. The first one is still at 3.23 volts. Now if we go to the chart here, so 3.22 is still at 30%. Third one was, let me see, 2.9, so that's basically exhausted. And the last one was at 3.1, which is at 15%. So this is the voltage chart for a 12 volt Lifepo4 battery. I just want to have a look at the actual meter that's built into this battery to check the calibration. So according to this, 100% charge is 13.6 volts, and basically 10% charge is 12 volts, which is kind of where we should be at a minimum. So let's have a look at the meter itself and see how that compares. I've actually disconnected the cells from the top cover of the battery here, and I literally have this meter or these terminals connected up to my bench power. You can see the voltage that I've got set here. I'm just going to see what voltage this guy goes down to, 75, 50, 25%, etc. So it may switch off during this process, so I'll try and activate it again quickly. So I'm just turning the voltage down now, so we're down to so this is around the point that it goes to 75%, which is about 11.8 volts. Let's just try and get that as accurate as possible. It's switched off again. Yeah, 11.87 volts, it goes down to 75%. It's around 11.35, it goes to 50%. It's about 10.7. (10.1) is the boundary between 25% and 0%. And quite clearly the voltage meter has Chinese on it, and it says according to Google Translate 3 skewers. I assume that means 3 cells. I think this is a meter for a 3-cell lithium ion battery. which is what I actually thought was inside of this guy to start with. I thought that's what I was going to find. What I expected to find was a 6-cell lithium ion battery, 3 lots of 2 cells in parallel, and that would kind of stack up with the voltages that I was kind of seeing out of this guy. So there we have it. It's not total lies what it says on the front label. It does in fact contain 4 32700 cells with a 30 amp BMS, as it says on the side of the BMS anyway. Unfortunately, the quality of construction is diabolical. The plus and minus wires, so the balance wires are fine being these thinner cables, but the main plus and minus supply wires from the cells themselves are very thin wire for 30 amps. I wouldn't really want to put any more than about 2 or 3 amps through those, to be fair. But it does say the maximum working current is 5 amps on here, but even so, 5 amps for those guys I don't think is really a great idea. The BMS itself doesn't seem to be able to balance correctly. I'm not a big expert on these things, but from my understanding, if one of the cells becomes fully charged, it should then shut down the main charging of the cells and then trickle charge the remaining cells until all the voltages are the same. This does not seem to be capable of doing that. When one of the cells reaches the shutdown voltage, which I think was 3.75 volts, it completely shuts off charging to the whole module, and then it will just cycle on and off full current charge until the cell regains its shutdown voltage, and then it will shut down again, and then a few moments later it will switch back on and charge at maximum current, etc. So it doesn't do any balancing unless the cells are quite close to each other, and then I think it probably does balance to a certain degree, but not how I would have expected. The voltage meter is not for a 4-cell LiPo battery at all. I believe it's for a 3-cell lithium ion or lithium polymer battery, 3.7/3.8 volt battery or cell, and it says quite clearly on there it's 3 skewers is the translation, but I think that probably means 3 cells. So really this thing is just a total waste of money, made with second-hand components, second-hand cells, which are in really bad looking condition. I can't actually see any markings on the cells themselves, so they're totally unidentified, a piece of junk. So that's it for this one. Hope you enjoyed that. Hope it's useful for somebody, and please do not buy one of these from any Chinese supplier, I would say. So I don't really see any reason to continue with this. The battery was sold as being new. Clearly it's not new. It has a capacity of just under 3 amp hours as opposed to the advertised 7. One of the cells is clearly totally defective. The other 3 maybe have some use.